Welcome to AP Biology. Today I'm going to go over some water potential problems or practice questions. So if you look at your formula sheet, you've got a bunch of equations on water potential here. So water potential is psi. And so here it is. Water potential is the pressure potential plus the solute potential. So psi P is the pressure potential, psi S is the solute potential. And it tells you right here that the water potential will be equal to the solute potential if the solution in the open container is in an open container because the pressure potential of the solution in an open container is 0. All that means is if you're in an open container, there's no pressure. And so that means the water potential equals the solute potential. And then the equation for solute potential is right here, negative I CRT. And all of those things are defined here. So I is the ionization constant. Sucrose and other sugars, lactose, maltose, glucose, whatever it is, these don't ionize. They're covalently bonded. So it's always going to be 1 for a sugar or for anything covalently bonded. If you have something like sodium chloride, it will separate out into 2 ions. And so your ionization constant would be 2. So I'll show you examples of that. But what it means is if you have a molarity of 0.5 molar sodium chloride, you're really separating that sodium chloride into 2 ions when it goes into water. And so it really has like double the number of solutes in there. C is the molar concentration, and that's in moles per liter because that's what molarity means. And then R is the pressure constant, so there's just this constant with these units that we'll use. And then T is always going to be in Kelvin. So you have to remember to switch that. Okay, so first question, water potential practice questions. And it says up here at the top that we're going to use 24 degrees Celsius if it's not otherwise specified. Whoops. Let's make you, whoops, see that? Okay, so here are the questions. Let's go in a little. Okay, so it says right here to use a temperature of 24 degrees Celsius for these problems, and then it also gives you a conversion factor if you need it for the pressure. So a membrane permeable only for water is inserted between 2 compartments. So here's a beaker, and you've got a membrane right here. And it says the left compartment has, you pour 0.5 molar glucose in it. So I always think it's a good idea to write down what the problem's telling us. Write down the knowns. And that way you know what you need to solve for later. And then the other side has 0.5 molar NaCl. So glucose doesn't ionize. Glucose is covalently bonded. It's going to have an ionization constant of 1, whereas sodium chloride does come apart in water. So you'll need to recognize, you'll need to recognize what's ionic. So a salt like sodium chloride will be ionic. And so that's going to have an ionization constant of 2. So calculate the solute potential for each solution. So in glucose, the solution, the glucose solution, you've got a solute. The solute potential is going to be negative I CRT. And that, if you don't have the formula, is right here on your formula sheet. And it even tells you what all these things are. So for sugar, it's going to be 1 for the solute, for the ionization constant. Don't forget your negative sign in front. And then the molarity is 0.5 molar. And so molar is really moles per liter, which you're going to need when you like cross out your units. C is going to be, that's C. R is going to be 0. Let's see, it's right here, 0.0831 liter bars per mole Kelvin. And then the temperature, it says up here is 24 degrees. So it's going to be 24 plus 273. And it says so right here. It says that Kelvin is Celsius plus 273. So okay, so I'm going to use a temperature of 297 Kelvin. So now look at my units. I can cross out the moles, top, bottom. I can cross out my liters, and I can cross out Kelvin, which leaves me in bars, which is what I want. So If I multiply all that stuff together, I get 12.3 bars. Okay, so now I want to do the sodium chloride one. And so that is almost the same calculation. We are still trying to find the solute potential. That's negative I CRT. The difference is just this ionization constant, because you're going to really have twice as many particles in this one as you do in this one, because the sodium separates from the chloride, so you have extra compartments. So it's negative 2 times 0.5, because it's the same molarity, and that's going to be moles per liter. And then the R is the same, liter bar per mole Kelvin. And then the temp's the same, 297 K. And so this ends up being negative 24 point, I think it's 7 bars. All right, so that's the general way to approach these. And I think I will end with that.